Section 3.7. Exercises. 1. Review the following function descriptions and determine if each is a leaf function. Provide reasons for your answers based on the complexity of the tasks the functions perform and whether they are likely to require calling additional custom functions. A. Scrape data. Given a list of URLs, scrape data from each page, parse the content to extract specific information, and save the extracted data to a database. B. Process customer orders. Given a list of customer orders, process each order by checking inventory, calculating total price with discounts and taxes, updating inventory, and generating an order summary. C. Find the largest number in a list. Given a list, return the largest value. D. Check whether a list contains a specific value. Given a list and a value, return true if the list contains the value and false if it does not. E. Generate student report cards. Given a list of students and their grades, calculate the final grades, assign letter grades, determine class rank, and generate a formatted report card for each student. 2. Review the cycle of designing functions with Copilot as outlined in this chapter. This cycle includes steps from determining the function's behavior to testing the generated code. Based on general programming practices, identify which of the following steps is not included in the cycle described, but is commonly part of a software development process. A. Verifying the logical correctness of the generated code by running unit tests. B. Editing the function's code manually to simplify complex logic after Copilot generation. C. Conducting performance benchmarks on the generated code to ensure efficiency. D. Consulting documentation or external resources to refine the function's prompt. 3. Based on the problem description provided, write a clear and concise prompt for Copilot that specifies the task to be completed. Ensure your prompt includes all necessary details such as expected inputs, the processing to be performed, and the expected output. A. In a quaint little town, there was a humble shopkeeper who, every so often, would delight his customers with discounts on his goods. To streamline this process, he sought to create a magical formula. This formula would take the original price of any item in his store and the special discount he wished to offer. With these two pieces of information, the formula would then reveal the final price the customer needed to pay after the discount was woven into the original tag, making both the shopkeeper and his customers very happy with the ease of their transactions. Can you think of 2 or 3 input examples to verify the correctness of the function generated by Copilot based on your prompts? Include some scenarios to ensure the function handles different types of input correctly and calculates the correct output. 4. Review the function description and the provided test cases for calculating the total cost of a meal, including tax and tip. Based on the scenario and typical requirements of such a function, can you think of inputs where the function doesn't work correctly? Explain why handling this input is necessary to ensure the function's reliability and correctness across all potential use cases. Problem description. Create a function that calculates the total cost of a meal, including tax and tip. The function should take 3 inputs: the base price of the meal, the tax rate as a percentage, and the tip rate as a percentage. The function should calculate and return the total cost of the meal. Test cases. A. Standard case. Calculate the total price of a $50 meal with a 10% tax and a 15% tip. Input: base price equals 50, tax rate equals 10, tip rate equals 15. Expected output: $62.50, calculated as $50 plus $5 tax plus $7.50 tip. B. Zero tip case. Calculate the total price of a $30 meal with a 5% tax and no tip. Input: base price equals 30, tax rate equals 5, tip rate equals 0. Expected output: $31.50, calculated as $30 plus $1.50 tax plus $0 tip. C. High tax and tip case. Calculate the total price of a $100 meal with a 20% tax and a 25% tip. Input: base price equals 100, tax rate equals 20, tip rate equals 25. Expected output: $145, calculated as $100 plus $20 tax plus $25 tip. 5. Review the initial prompt provided to Copilot and the resulting Python function. The code doesn't fulfill the requirements as it only converts from Fahrenheit to Celsius, and lacks the capability to convert in both directions based on a user-specified mode. How would you improve the prompt to ensure that the generated code meets the full requirements of the problem description?
See this code?